Hello, and welcome back to the Python OOP series. In the previous video, we learned about inheritance and different types of inheritance. Today, we are going to learn one of the most important concepts in object-oriented programming called polymorphism. This concept is heavily used in backend development, large software systems, frameworks like Django, and even in machine learning libraries such as scikit-learn. By the end of this video, you'll understand what polymorphism is, why engineers use it, and how it helps us write cleaner and more scalable code. So let's get started. Now, before we talk about polymorphism, let's quickly recap what we've learned so far. Inheritance allows child classes to inherit attributes and method from their parent classes. Method overriding allows a child class to provide its own implementation of an inherited method. When we combine inheritance and method overriding together, we get polymorphism. You can think of it like this. Inheritance creates the relationship, and method overriding creates different behaviors. Polymorphism allows us to use those different behaviors through a common interface. Keep that idea in mind because everything in this video builds on it. Now, what is polymorphism? Now, polymorphism comes from two Greek words. Poly means many and morph means forms. So polymorphism literally means many forms. In programming, polymorphism means that the same method call can behave differently depending on the object receiving that call. The method name is the same, but different objects can perform different actions. This allows us to write code that focuses on what an object can do instead of worrying about exactly what type of object it is. This makes software more flexible and easier to extend. One interesting thing is that you've already been using polymorphism since you started learning Python. Take a look at these examples. Len hello returns 5. Len 123, which is a list, returns 3. The same function is being used, but Python behaves differently depending on the object. Let's look at another example. 10 plus 20, which are of type integers, both values, return 30. Hello plus word, which are strings, return hello world. The plus operator is the same, but it performs different operations depending on the data type. That's polymorphism. Same interface, different behavior. Now let's see how polymorphism works in object-oriented programming. Imagine we're building an online payment system. We have a parent class called payment. Then we have three child classes, credit card, PayPal, and bank transfer. All of them have a method called process payment. The method name is identical, but the implementation is different. A credit card payment needs card validation. PayPal requires authentication. A bank transfer may require communication with the bank API. Same method, different logic. That's polymorphism through inheritance. Now, let's have a look at polymorphism through code. Now let's try and implement a basic version of a production payment system. Now, let's make our first class, which is payment. Now, let's add a method called process payment. Pass self and print processing payment. Now, let's make another class, credit card, pass payment. Now credit card is the child of payment. Define process payment again. Now let's not return super. Write print processing credit card payment. Alright. Now let's implement class PayPal. Pass payment again. Now PayPal 2 is a child of payment. Define the process again and print processing PayPal payment. Now let's implement our final class, bank transfer. Pass payment again. Define the process again and print processing bank transfer. Now Let's create some objects. Now we go payments is equals to a big bracket, credit card, PayPal, and our final bank transfer. Notice that all these objects are stored inside the same list. That's possible because they all share the same interface. Now let's use polymorphism. Now let's write a loop for payment in payments. Payment dot process payment, and then we run the code. Let me open my terminal, type python main.py, which is my file name. As you can see, our output is processing credit card payment, processing PayPal payment, and processing bank transfer. This is the moment where polymorphism becomes powerful. Look carefully. We never wrote if instance or any kind of if statement. We never checked the class type. We simply called payment.processPayment. Python automatically determined which version of the method should run. For credit card object, Python called the credit card version. For PayPal object, Python called the PayPal version. And for the bank transfer object, Python called the bank transfer version. One method call, 3 different behaviors. This is polymorphism. Now let's talk about why experienced software engineers use polymorphism. Without polymorphism, code often looks like this, a bunch of if and else statements together. Now imagine in this example, the company decides to add Apple Pay, Google Pay, crypto, international wire transfer, and bunch of other payment methods. This would mean the conditional block or the if-else statements would keep on growing. The code then becomes much harder to maintain, and with polymorphism, all of that just becomes payment.processPayment, just like in our previous example or here. If tomorrow we create a new payment class, we don't have to modify the existing code. We simply create a new class and implement the method. This is one reason why polymorphism helps create scalable software systems. Now, since many of you are probably interested in AI and machine learning, let's see a real-world example. Imagine a machine learning pipeline. We may have different models, a random forest model, XGBoost model, a deep learning neural network model, etc. Even though the internal algorithms are completely different of these models, they often expose the same methods, for example, fit or predict. Now, the training pipeline does not need to know which model it's working with. It simply calls model.fit or model.predict, and each model performs its own implementation. This is exactly how production AI systems and machine learning libraries are designed. Polymorphism is not just a classroom concept. It is used every day in real software systems. Now, let's quickly recap. Polymorphism means many forms. The same method call can behave differently depending on the object. Polymorphism is usually achieved through inheritance and method overriding. It helps eliminate large if-else chains. It makes software easier to maintain and extend, and it's widely used in backend systems, frameworks, and AI applications. Now, in the next video, we'll learn about abstract base classes or ABCs and see how professional developers enforce rules and contracts between classes. If you found this video useful, make sure to like this video, subscribe to the channel, and let me know in the comments what OOP topic you found most interesting so far. Thanks for watching, and I'll see you in the next one.